Welcome to the basic mathematics. The permutation and the combinations. The permutation and the combinations. Let's talk about the permutation. The permutation means arranging the items in a certain order or in a unique way from a set of certain items. The combination here means in mathematics is selecting items from a group of items without considering any order. In this video, we will learn formulae for permutations and combinations. The permutations of n objects. Npn equals n factorial. Factorial of n means equals n times minus 1 times n minus 2 times 2 times 1. Permutations of our number of objects out of n number of objects. 0 less than or equal to r less than or equal to n. NPR equals factorial n divided by factorial nr. When repetitions are not allowed, NPR equals n to the power of r. When repetitions are allowed, NPN equals factorial n divided by factorial p. When objects p out of n objects are not distinct. Combinations of our number of objects out of n number of objects, where 0 less than or equal to r less than or equal to n. NCR equals factorial n divided by factorial r times factorial n minus r. Also note other formulae. Permutation versus combination. We will try to learn basic difference between permutation and combination. In permutation, order is important, and the combination loosely means don't think of any order you buy from a store. Green apple, banana and pear for your fruit salad. Green apple, banana and pear are same for your fruit salad plate. That is the combination of fruits. Take a key of a number lock. You set it using digit 2, 4 and 6. Or think A for letter password. You made using letters PORK. You know it is not sufficient just to know 3 digits or 4 letters, but it is more important and necessary that you know the order of digits for your lock key or letter in password, because the number of ways 3 digits can be used, or the permutation of 2, 4 and 6 are 246, 264, 462, 426, 624, 642. You have noted that there are 6 ways of the possible order, or the permutation equals 6. The 4-letter password you made using letter PORK. It is important to know the order of letters in the password, because the number of ways for letters can be used are pork, poker, proc, PRKO, PCOR, PKRO, ORKP, ORPK, OKRP, OKPR, OPRK, OPKR, RKPO, RCOP, RPOC, RPKO, ROC, ROC, KPOR, KPRO, copper, Corp, KRPO, crop. For times 6 is equal to 24. Other possible ways or permutation of 4 letters. Let's explore more on combination. For a team, 1 player is needed for 1 vacant place. In the team, the coach has to select 1 boy from number of boys. So there are many possible way or combination. If only 1 boy is available, so there is no other way but to select him, or mathematically 1 selection possible. If 2 boys are available, so there are 2 ways but to select either 1 or 2, or mathematically 2 selections possible. If 3 boys are there, 3 possibilities either of 1, 2, 3. This only means for n number of boys. There are n number of possibilities. If we have to select only 1, today, 2 players are absent, and the coach has to select 2 boys from number of boys. We explore it now. If only 2 boys #1 and number 2 are available, so there is no other way but to select both, or 1 possible combination of selection. If 3 boys number 1, number 2, and #3 are available, so there are 3 ways to select them: #1, number 2, and #3 or 3 selections possible. If 4 boys #1, number 2, #3 and #4 are available for 2 vacancies, there are 6 ways to select them: #1 and #2, number 2, and #3, and number 4, number 1, and #3, #1, and #4, #2, and #4. Mathematically, 2 out of 4. There are 6 possible combination of selection. Another day, 3 players are absent, and the coach has to select 3 boys from number of boys. We explore it now. If only 3 boys numbered as 1, 2, and 3 are available, so there is no other way but to select all, or mathematically 1 possible selection. If 4 boys numbered 1, 2, 3 and 4 are available, so there are 4 ways to select them: 1, 2, 3, 2, 3, 4, 1, 2, 4, 1, 3, 4, or mathematically for selections possible. If 5 boys numbered as 1, 2, 3, 4, 5 are available for 3 vacancies, note there are 10 ways to select them. Or there are 10 possible combination of selection. If 6 boys numbered as 1, 2, 3, 4, 5 and 6, are available for 3 vacancies. You may note there are 20 ways to select them. Or there are 20 possible combination of selection. It is clear that the number of ways the selection is possible depends on the number of players available and number of vacancies in the team. So, we may generate a formula to calculate it. Before we move further on combinations, let's explore now the permutation, where the order of selected boy is important, as he will be placed in some order of importance of place. For a team, a place of captain is vacant and the coach has to select one boy from number of boys. So there are many possible ways. If only one boy is available, there is one way. Make him captain. For 2 boys, there are 2 possible permutation. Or for n number of boys to be selected as captain and n number of permutation possible. Actually, the permutation does not matter for one person. But if there are 2 places, that of captain and of goalkeeper, are to be filled, the coach can select from 2 boys numbered as 1 and 2. In 2 permutation, number 1, make number 2 captain and numbered 1 goalkeeper, and number 2, make numbered 1 captain and numbered 2 goalkeeper. If 3 boys numbered as 1 and 2 and 3 are available, the coach can select from 3 boys. So, note there are 6 ways to select them as captain and goalkeeper. In permutation, placing is important. That's why the number of selection are more in permutation than in combination. If 4 boys numbered 1, 2, 3, and 4 are available for 2 vacancies of the captain and the goalkeeper, there are 12 ways to select them. Or 4 times 3 is equal to 12. See table below. If 5 boys numbered 1, 2, 3, and 4 and 5 are available for 2 vacancies of the captain and the goalkeeper, there are 20 ways to select them. Or 5 times 4 is equal to 20. See table below. If 6 boys numbered 1, 2, 3, 4 and 5 and 6 are available for 2 vacancies of the captain and the goalkeeper, there are 30 ways to select them, or 6 times 5 is equal to 20. If 7 boys numbered 1 to 7 are available for 2 vacancies of the captain and the goalkeeper, there are 42 ways to select them, or 7 times 6 is equal to 42. If 8 boys numbered 1 to 8 are available for 2 vacancies of the captain and the goalkeeper, there are 56 ways to select them, or 8 times 7 is equal to 56. If n number of boys are available for 2 vacancies of the captain and the goalkeeper, there are number of ways to select them are n times n minus 1. In permutation, the placing is important. So now we explore the selections. For 3 boys for 3 positions, the captain, the vice-captain and a goalkeeper are to be selected, and 3 boys numbered as 1, 2 and 3 are available. You may note that there are 6 ways to select them, or 3 times 2 times 1 is equal to 6. Now we find out the permutation for 4 boys and 3 positions in a team. If 4 boys numbered as 1, 2, 3 and 4 are available, there are 24 ways of the selection, or 4 times 3 times 2 is equal to 24. Now we find out the permutation for 5 boys and 3 positions of the captain, vice-captain and goalkeeper in a team. If 5 boys numbered as 1, 2, 3, 4 and 5 are available, so there are 60 ways equals 5 times 4 times 3 is equal to 60. The permutation for 6 boys and 3 positions, there are 120 ways the selection can be done, or 6 times 5 times 4 is equal to 120. The permutation for n boys and 3 positions, it is or. The number of selection equals n times n minus 1 times n minus 2. The permutation for n boys for 4 positions equals n times n minus 1 times n minus 2 times n minus 3. And the permutation for n boys and 6 positions, it is equals n times n minus 1 times n minus 2 times n minus 3 times n minus 4 times n minus 5. Permutation with repetition. In the beginning, we discussed for letter password, using letter PORK, with the intent not to repeat any letter. The number of ways for letters could be used are shown here again. Is equal to 4 times 3 times 2 times 1 equals 24. In second type of permutation, if we Allow repetition. So for letters password, using letter PORK, could also be PPPP, OOOO, POOK, RPPP, etc. It adds up many other possibilities and number of permutation will increase. In permutation, with repetition, we allow repetitions. So any of 4 letters, say A, B, C, and D, can come to any place, irrespective of what it is at adjacent places. To fill first place, there are 4 possible ways, that is either of A, B, C, and D. For second place also, we have 4 possible ways. So is for third place, and is for fourth place. So total number of all possibility or possible permutation is 4 times 4 times 4 times 4 equals 4 to the power of 4 equals 256. In permutation, with repetition, 5 letters, say A, B, C, D, and E. And to make for letter password, to fill first place, there are 5 possible ways, that is either of A, B, C, D, and E. For second place also, we have 5 possible ways. So is for third place and is for fourth place. So total number of all possibility or possible combinations are 5 times 5 times 5 times 5 equals 5 to the power of 4 equals 625. In permutation, with repetition, 6 letters, say A, B, C, D, E, and F. And to make for letter password, so total number of all possibility or possible combinations are 6 times 6 times 6 times 6 equals 6 to the power of 4 is equal to 1296. In permutation with repetition, it is the easier to calculate when we have n different type of items and we have n choices each time. So, for choosing 3 items out of n different type of item, the permutation are n times n times n equals n to the power of 3. And for choosing for items out of n type of item, the permutation are n times n times n times n equals n to the power of 4. Therefore, for choosing a number of items out of n number of type of items, provided r is less than equals n, the permutation is n times n times n times r times equals n to the power of r. Do you know about factorial of numbers? Let's recollect our knowledge about factorial of number, say n, or factorial n. Factorial of a number. The factorial of a number is the product of all positive integers or numbers less than and equal to that number. Start with factorial 1 is equal to 1. Also, mathematician agrees factorial 0 is equal to 1. Factorial 2 equals 2 times 1 equals 2. The factorial of 2 is the product of numbers less than or equal to 2. Factorial 3 equals 3 times 2 times 1 is equal to 6. The factorial 3 is the product of all numbers less than or equal to 3. Factorial 4 equals 4 times 3 times 2 times 1 is equal to 6 equals 24. The factorial 4 is the product of all numbers less than or equal to 4. The factorial of a number is the product of all positive numbers less than and equal to that number. Factorial 5 is equal to 5 times 4 times 3 times 2 by 1 equals 120. The factorial 5 is the product of all numbers less than or equal to 5. Factorial 6. 6 times 5 times 4 times 3 times 2 times 1 is equal to 720. The factorial 6 is the product of all numbers less than or equal to 6. Factorial n equals n times n minus 1 times n minus 2, so on to 1. The factorial n is the product of all numbers less than or equal to n. Multiplication of two factorial numbers is just the product of those numbers. Factorial 2 times factorial 3 equals 2 times 1 times 3 times 2 times 1 equals 2 times 6 is equal to 12. Or factorial 4 times factorial 5 is equal to 2880. Division of two factorial numbers is: divide one factorial by another factorial. Note, when you divide one factorial by another factorial, write all numbers which are in factorial, and see many of them are cancelled out, giving you simple answer. Factorial 6 divided by factorial 5 is equal to 6. So is factorial n divided by factorial n minus 1 is just n. And so on. Permutation formula. Earlier, we calculated the permutation of placing 3 boys for 3 positions. Let's say, for a team, a place of captain, vice-captain and keeper are to be filled with 3 boys. The number of permutation equals 3 times 2 times 1 is equal to factorial 3 is equal to 6. Earlier we also calculated the permutation of placing 4 letters for letter password. The number of permutation equals 4 times 3 times 2 times 1 equals factorial 4 is equal to 24. Therefore, the permutation of placing 5 objects, the number of permutation equals 5 times 4 times 3 times 2 times 1 equals factorial 5 is equal to 120. In factorial numbers, we can write permutation for n boys as npn equals n factorial. We noticed and calculated the permutation of placing 5 boys for 3 positions of captain, vice-captain and keeper in a team. The number of permutation is equal to 5 times 4 times 3 equals 60. For 6 boys and 3 positions of captain, vice-captain and goalkeeper, the number of permutation is equal to 6 times 5 times 4 equals 120. Generalizing it, for n boys and 3 positions, the number of ways the selection can be done equals n times n minus 1 times n minus 2. And for n boys and for 4 selected positions, permutation r equals n times n minus 1 times n minus 2 times n minus 3. In factorials, we can write permutation for n boys and for positions equals n times n minus 1 times n minus 2 times n minus 3. Now by multiply and divide by factorial n minus 4, the permutation can be written as equals n times n minus 1 times n minus 2 times n minus 3 times factorial n minus 4 divided by factorial n minus 4 equals factorial n divided by factorial n minus 4. The permutation formula for our items from n items is NPR equals factorial n divided by factorial n minus r. We symbolize the permutation as NPR. Sometimes P, N, R, NPR are also used. Combinations. Earlier, we explored the possible combinations and we observed that if we have to select 3 items out of 3 available items, then there is only one way. Or if we have to select 4 items out of 4 available items, then again, there is only one way. However, if we select 3 items from 4 items available, then there are 4 ways to select them. For possible combinations, if we select 3 items from 5 items available, so there are 10 ways to select them. Number of combinations equals 10. If 6 boys numbered as 1, 2, 3, 4, 5, 6 are available for 3 vacancies, there are 20 ways to select them, shown here. Or mathematically 20 selections. Or 6 times 5 times 4 divided by 2 times 3 is equal to 20. It is clear that the number of possible selection depends on the number of players, say n, available, and number of vacancies, say r, in the team. So we can generate a formula of possible combinations using n and r. If n is the number of players are available and r is number of vacancies in the team, or the number of combination of r objects out of n objects is defined as NCR. In factorial, we can write combination formula for 6 boys and 3 position 6C3 equals 6 times 5 times 4 divided by 2 divided by 3 is equal to 20. Now, by multiply and divide it by factorial 3, we can write 6C3 equals factorial 6 divided by factorial 3 times factorial 3. Combinations formula is similar to permutation formula, with modification to reduce it by 1 divided by factorial r. NCR equals factorial n divided by factorial r times factorial n minus r, where r is the number of items chosen from n number of item. We symbolize the combination as NCR. Also in use, C, N, R, and NCR. Formula for permutation without any repetition is NPR equals factorial n divided by factorial n minus r. Formula for permutation with repetition is NPR equals n to the power of r. Formula for combination without any repetition is NCR equals factorial n divided by factorial r times factorial n minus r. Combination formula. Verification. We verify. Formula. NCR equals factorial n divided by factorial r times factorial n minus r. For case we worked earlier, if we select 3 items from 4 items available, so there are n equals 4 and r equals 3. For C3 equals factorial 4 divided by factorial 3 times factorial 4 minus 3 equals 4. If we select 3 items from 5 items available, so there are 10 ways to select them equals 5. C3 equals factorial 5 divided by factorial 3 times factorial 5 minus 3 equals 120 divided by 12 is equal to 10. If we select 3 items from 6 items available, so there are 20 ways we found now equals 6. C3 equals factorial 6 divided by factorial 3 times factorial 6 minus 3 is equal to 20. Some exercise with formulae. Example number 1. How many numbers of 2 digits can be formed from the digits 0 to 9? 1. If no digit is repeated. 2. With repetition of digits. 1. If no digit is repeated. We use formula for permutation. NPR equals factorial n divided by factorial n minus r. Here n equals 10 and r equals 2. Hence 10p2 equals factorial 10 divided by factorial 10 minus 2 equals factorial 10 divided by factorial 8 equals 10 times 9 equals 90. Number 2. With repetition allowed equals p equals n to the power of r equals 10 squared 2 is equal to 100. We know there are 100 numbers from 00 to 99. We also know there are 10 numbers of same double digit starting from 00, 11, 22 to 99. That's why we got the answer 90 in first case. Example number 2. How many numbers of 3 digits can be formed from the digits 0 to 9? 1. If no digit is repeated. 2. With repetition of digits allowed. 1. If no digit is repeated. We use formula for permutation. NPR equals factorial n divided by factorial n minus r. Here n equals 10 and r equals 3, hence 10p3 equals factorial 10 divided by factorial 10 minus 3 equals factorial 10 divided by factorial 7 is equal to 720. 2. With repetition allowed. P equals n to the power of r equals 10 cubed equals 1000. Here we have 1000 numbers from 0 to 999. We also know that there are 10 numbers of same 3 digits, such as 000, 111, 222. 90 numbers with first 2 digits same, such as 001, 111, 221. 90 numbers with last 2 digits same, such as 011, 022, 033. And 90 numbers with first and last digits same, such as 101, 121, 131. So we have 270 numbers with repetition of digits. In this sum of 270, we have to include 10 same triple-digit numbers in this 270 numbers. So we add 10 to 270 is equal to 280. We have 1000 minus 280 equals 720. These examples help us to understand the difference between with repetition and without repetition. Example number 3. How many ways 2 digits are selected? From 10 digits 0 to 9. We use formula. For combinations, as we are not talking about the order, NCR equals factorial n divided by factorial r times factorial n minus r. Here n equals 10 and r equals 2. Therefore 10C2 equals factorial 10 divided by factorial 2 times factorial 8 is equal to 45. In case of permutation of 2-digit numbers out of 10 digits, therefore 10p2 equals factorial 10 divided by factorial 10 minus 2 equals factorial 10 divided by factorial 8 is equal to 10 times 9 equals 90. Note: 2-digit numbers like 23, 32 or 45, 54 are considered same in combination, hence the permutation number is divided by factorial 2. Note the relation between the two. NPR equals NCR times factorial. Example number 4. How many ways 3 digits are selected? From 10 digits 0 to 9. We use formula. For combinations, NCR equals factorial n divided by factorial r times factorial n minus r. Here n equals 10 and r equals 3. Therefore 10C3 equals factorial 10 divided by factorial 3 times factorial 7 is equal to 120. Here number of 3-digit numbers, such as 123, 132, 213, 231, 312, 321 are considered as one selection, instead of 6, in permutation. The permutation number 10p3 equals factorial 10, divided by factorial 7 is equal to 720. Is divided by 6 or factorial of 3, that's why you see factorial 3 in denominator in the formula of combinations of 10C3 equals 10C3 equals factorial 10 divided by factorial 3 times factorial 7. Note, again the relation between the two. NPR equals NCR times factorial. Example number 5. How many ways 3 digits and 7 digits are selected? From 10 digits 0 to 9. We use formula. For combinations, NCR equals factorial n divided by factorial r times factorial n minus r. For 3 digits n equals 10 and r equals 3. Therefore 10C3 equals factorial 10 divided by factorial 3 times factorial 7 is equal to 120. For 7 digits n equals 10 and r equals 7. Therefore 10C7 equals factorial 10 divided by factorial 3 times factorial 7 is equal to 120. The result is same for both the cases of 3 digits and 7 digits. 10C7 equals factorial 10 divided by factorial 3 times factorial 7 equals 10C3. Due to symmetry of formula, therefore NCR equals NCN minus R. Example number 6. Given that NC5 equals NC4, calculate NC2. As we can compare with the formula NCR equals NCN minus R. By comparing it, N equals 9. Now we confirm it by calculation. n c5 equals factorial n divided by factorial 5 times, factorial n minus 5 equals n c4 equals factorial n divided by factorial 4 times, factorial n minus 4. Solving the equation further. Or factorial 4 times n minus 4 times factorial n minus 5 divided by 5 times factorial 4 times factorial n minus 5 is equal to 1, or n 4 equals 5. Therefore n equals 9. Now n c2 or 9c2 equals factorial 9 divided by factorial 2 times factorial 9 minus 2 equals 36. Example number 7. Given that nc6 equals nc4, calculate nc3. nc6 equals factorial n divided by factorial 6 times factorial n minus 6 equals nc4 equals factorial n divided by factorial 4 times factorial n minus 4. Solving the equation further, we open factorial. Factorial 4 times n minus 4 times n minus 5 times factorial n minus 6 equals 6 times 5 times factorial 4 times n minus 6, or n minus 4 times n minus 5 equals 30. It is a quadratic equation. N square minus 9n plus 20 minus 30 equals n square minus 9n minus 10. To solve further, we factorize as n square minus 9n minus 10 equals n square minus 10n plus n minus 10 equals n minus 10 times n plus 1 equals 0. Therefore either n equals 10 or n equals minus 1. As n equals minus 1 is not possible, so therefore n equals 10. Now nc3 or 10c3 equals factorial 10 divided by factorial 3 times factorial 10 minus 3 equals 120. Example number 8. What are the number of ways of selecting for cards from a pack of 52 playing card? This case is simple. We have 52 cards and have to select 4 card. So n equals 52 and r equals 4. Using the formula NCR. And so 52c4 equals factorial 52 divided by factorial 4 times factorial 52 minus 4 equals 52 times 51 times 50 times 49 divided by 4 by 3 by 2 equals 270,725. Example number 9. What are the number of ways of selecting for cards from a pack of 52 playing card? Provided all 4 cards should be a picture cards, King, Queen, and Jack. In the playing cards, there are 4 suits: Diamond, Club, Heart and Spade. And each suits has Jack, Queen and King. So we have 12 picture cards and we have to choose 4 picture cards. 12c4 equals factorial 12 divided by factorial 4 times factorial 12 minus 4 equals 12 times 11 times 10 times 9 divided by 4 times 3 times 2 times 1 equals 11880 divided by 24 is equal to 495. Example number 10. What are the number of ways of selecting 4 cards from a pack of 52 playing card? Provided that 4 cards should be 1 from each suit: Club, Spade, Heart and Diamond. There are 13 cards in one suit and Choosing 1 out of 13 cards is 13C1 equals 13, as there are 4 suits: club, spade, heart and diamond. So for each one card, we have 13 combinations. Therefore, total number of ways of selecting 4 cards is equal to 13 times 13 times 13 times 13 equals 28,561. Example 11. What are the number of ways of selecting 4 cards from a pack of 52 playing card, provided that all 4 cards should not be a picture card? In the playing cards, there are 4 suits: diamond, club, heart and spade, and each suit has jack, queen and king. So if we remove 12 picture cards and we have to choose 4 cards from 40 cards, so it is 40C4 equals 40 times 39 times 38 times 37 divided by 4 by 3 by 2 equals 2193360 divided by 24 is equal to 91,390. Example number 12. What are the number of ways of selecting 4 cards from a pack of 52 playing card, provided that all 4 cards should be 2 black and 2 red? There are 26 black cards and 26 red cards, and choosing 2 black cards out of 26 black cards is 26C2 is equal to 26 times 25 divided by 2 equals 325. 2 red cards out of 26 red cards is 26C2 is equal to 26 times 25 divided by 2 is equal to 325. Therefore, total number of ways of selecting 2 plus 2 is equal to 4 cards is equal to 325 times 325 equals 105,625. Example number 13. What are the number of ways of selecting 4 cards from a pack of 52 playing card, provided that all 4 cards should be of 1 suit? There are 13 cards in 1 suit, and choosing 4 out of 13 cards is 13C4 equals 13 times 12 times 11 times 10 divided by factorial 4 is equal to 17,160 divided by 24 equals 715. As there are 4 suits: club, spade, heart and diamond, so can be total combinations. Therefore, total number of ways of selecting 4 cards equals 715 plus 715 plus 715 plus 715 equals 2,860. Example number 14. If we draw 3 balls and 4 balls from 9 balls in a box, and draw 4 balls from 10 balls, find the number of ways or possible combinations in all 3 cases. Is there any relation among 3 cases? Number of combinations for 3 balls from 9 balls: 9C3 equals factorial 9 divided by factorial 3 divided by factorial 9 minus 3 equals 9 times 8 times 7 divided by 3 by 2 equals 84. Number of combinations for 4 balls from 9 balls. 9c4 equals factorial 9 divided by factorial 4 divided by factorial 9 minus 4 equals 9 times 8 times 7 times 6 divided by 4 by 3 by 2 equals 126. Number of combinations for 4 balls from 10 balls. 10c4 equals factorial 10 divided by factorial 4 divided by factorial 10 minus 4 equals 10 times 9 times 8 times 7 divided by 4 by 3 by 2 equals 210. From the answer 84 plus 126 is equal to 210, or 9c3 plus 9c4 equals 10c4. If we let n equals 9 and r equals 4, we can rewrite NCR minus 1 plus NCR equals n plus 1 CR. NCR minus 1 plus NCR equals n plus 1 CR. Is it true universally? Let's verify it. NCR 1 plus NCR equals n plus 1 CR. Write NCR 1 plus NCR equals factorial n divided by factorial r minus 1 divided by factorial n minus r plus 1 plus factorial n divided by factorial r divided by factorial n minus r. Open the factorials in the denominator and take out common factors and solve the bracket first. Factorial n divided by factorial r minus 1 divided by factorial n minus r in bracket 1 by n minus r plus 1 by r bracket closed. Bracket is solved as r plus n minus r plus 1 whole divided by n minus r plus 1 times r. Rewrite it as equals n plus 1 times factorial n whole divided by r times factorial r minus 1 times n plus 1 minus r times factorial n minus r equals factorial n plus 1 divided by factorial n plus 1 minus r divided by factorial r equals n plus 1 CR. Therefore NCR 1 plus NCR equals n plus 1 CR is true for all cases. The permutation. Earlier we discussed and shown you how many ways the 4-letter password using letter PORK are possible. There were 24 permutations, or it is factorial 4 if the letters in the password are not repeated. However, if repetition is allowed in the order of letters, permutation increases to n to the power of n. Now we discuss third type of permutation, where all 4 letters are not different, or some of the letters are same or not distinct. Let's say POOK instead of PORK. In case of 4 letters POOK, if we identify 200 as 01, 02, permutation number will be same as 4 or 24. But in fact 2 permutation P0102K and P0201K are same. To understand further, let's replace R in PORK by O to POOK, and we write all possible combination. You note the difference here. In this case of 4 letters P00K, P0102K, and P0201K are same or 2 possibilities turned into 1. So all 24 permutations can be divided by 2 or factorial 2. The permutations of 4 objects. When 2 objects out of 4 objects are similar, not distinct. For P4 equals factorial 4 divided by factorial 2 is equal to 12. In case of 4 letters P000, with 3 same letters, possible permutation are P000, OP00, OOPO, OOP equals just 4. The permutations of 4 objects. When 3 objects out of 4 objects are similar, not distinct, for P4 equals factorial 4 divided by factorial 3 equals 4. The permutations of 4 objects. When 2 objects out of 4 objects are similar, not distinct, for P4 equals factorial 4 divided by factorial 2 equals 12. The permutations of 4 objects. When 3 objects out of 4 objects are similar, not distinct, for P4 equals factorial 4 divided by factorial 3 equals 4. The permutations of n objects. When some objects, say P1, P2, out of n objects are similar, not distinct, of which P1 is of one kind and P2 is of second kind. NPN equals factorial n divided by factorial P1 times P2. To explain the permutation and its formula, NPN equals factorial n divided by factorial P1 times P2. We take an example of word mathematics. In case of mathematics, out of 11 letters, there are 2M, 2T, and 2A. Here not 1, but 3 letters are appeared twice. It means to get correct permutation, we have to divide number of permutation of 11 letters by 2. Thrice 11p11 equals factorial 11 divided by factorial 2 times 2 times 2 equals 3991680 divided by 2 divided by 2 divided by 2 equals 4989600. To explain the permutation and its formula, NPN equals factorial n divided by factorial P1 times P2. Consider another word, institute. It has 9 letters. Number of permutation equals factorial 9 equals 362,880. Note in this word institute, there are 3 or T and 2 I. So to get correct permutation, we have to cut down the common permutation involving T by dividing it by factorial 3, and involving I by dividing it by 2. The correct permutation is 9p9 equals factorial 9 divided by factorial 3 divided by factorial 2 equals 362,880 divided by 12 equals 30240. Therefore, we can generalize the formula as the permutations of n objects when some objects out of n objects pi are similar, not distinct. P1 is of one kind, P2 is of second kind, or pk of kth kind. NPN equals factorial n divided by factorial P1 divided by factorial P2, and so on to divided by factorial pk. Example 15. Find the number of permutations of the letters of the word independent. There are 12 letters in the word independent. Note here, out of all 12 letters, letter N appears 3 times. Letter E appears 4 times. Letter D appears 2 times. So to get correct permutation, we have to cut down the common permutation involving N by dividing it by factorial 3, involving E by dividing it by factorial 4, and involving D by dividing it by factorial 2. The permutation can be calculated by formula NPN equals factorial N divided by factorial P1 divided by factorial P2 divided by factorial Pk. The correct permutation is using the formula NPN equals factorial N divided by factorial P1 divided by factorial P2 divided by factorial Pk. We have 12P12 equals factorial 12 divided by factorial 3 divided by factorial 4 divided by factorial 2 equals 1663200. Example 16. Find the number of permutations of the letters of the word independent. How many permutations are possible if each word start with P? Out of 12 letters in the word independent, we have 3 letter N for letter E and 2 letter D. In the arrangement, first letter is always P. We are left with only 11 letters to place. With duplication in mind, we use the formula NPN equals factorial N divided by factorial P1 divided by factorial P2 divided by factorial Pk. We have 11P11 equals factorial 11 divided by factorial 3 divided by factorial 4 divided by factorial 2 equals 3991680 divided by 288 equals 138,600. Example 17. Find the number of permutations of the letters of the word independent. How many permutations are possible if 1. The vowels are always together, 2. Never together. In first case, there are 4 vowel letter E and 1 vowel letter I. That makes all vowel to 5. E-I. To solve this problem, we consider all 5 vowel as 1 unit, with this unit and 7 more letters, which makes it total 8, including 3 letter N and 2 letter D. The permutations can be calculated using the formula NPN equals factorial N divided by factorial P1 divided by factorial P2 divided by factorial Pk. Therefore the required permutations 8P8 equals factorial 8 divided by factorial 3 divided by factorial 2 equals 40,320 divided by 12 is equal to 3,360. Note: we have taken all 5 vowels as one unit, but within one unit, or in the group of 5 vowels, they can be arranged in different ways as 5p5 equals factorial 5 divided by factorial 4 equals 5. Remember, there are 4 letters E. We have already found 8p8 equals factorial 8 divided by factorial 3 divided by factorial 2 equals 3,360. Therefore, total number of ways equals 3,360 times 5 is equal to 16,800. In the part 2, vowels are never together. It can be calculated as total number of ways without any restriction minus the number of ways when all vowels are together, as calculated in part 1. p12 equals factorial 12 divided by factorial 3 divided by factorial 4 divided by factorial 2 equals 479001600 divided by 288 equals 1663200 minus the number of ways where all vowels are together, that is 16,800. Therefore, the required permutation equals 1663200 minus 16,800 equals 16464000. Example 18. Find the number of permutations of the letters of the word independent. How many permutations are possible if all words start with I and ends with P? Out of 12 letters in the word independent, we have 3 letter N for letter E and 2 letter D. In the arrangement, first letter is always I and last letter P. Now, we are left with only 10 letters to place. With duplication in mind, we use the formula NPN equals factorial n divided by factorial 1 divided by factorial p2 divided by factorial pk. We have 10p10 equals factorial 10 divided by factorial 3 divided by factorial 4 divided by factorial 2 equals 3628800 divided by 288 is equal to 12,600. Example 19. What are the number of ways in which a team of 11 players can be selected from 22 players after 2 are selected as captain and goalkeeper, and for of 22 player are found unfit? There are 22 players. 2 are already in the team, so we are left with 20 players and 9 places to be filled. It is also noticed that there are 4 players who are unfit and not be selected, so we are left with 16 players and 9 places to be filled. Number of combinations: 16C9 equals factorial 16 divided by factorial 9 divided by factorial 16 minus 9 equals 16 times 15 times 14 times 13 times 12 by 11 by 10 divided by in bracket 7 by 6 by 5 times 4 by 3 by 2 equals 5765760 divided by 5040 equals 11,440. Example 20. Everybody in a room shakes hands with everybody else. The total number of handshakes is 66. Find the total number of persons in the room. Let the number of person in the room is n. For a shaking hand, we need 2 person. So total number of handshakes are equals NC2. Note: shaking hand of person 1, P1, with P2 is same as shaking hand of P2 with P1. Considering permutation of n persons, divide NP2 by 2 factorial. Therefore 66 equals NC2 equals factorial n divided by factorial n minus 1 divided by factorial 2. Or 66 times 2 is equal to n times n minus 1. Or n square minus n minus 32 is equal to 0. It is quadratic equation. We can solve it by factorization, or rewrite the equation and factors are n minus 12 times n plus 11 equals 0. Therefore either n equals 12 or n equals minus 11, as n equals minus 11 is not possible. So the total number of persons in the room, or n equals 12. Example 21. In an examination, there are 3 multiple choice questions, and each question has 4 choices. Find the number of ways in which a student can fail to get all answer correct. There are 3 multiple choice questions, and each question has 4 answers. Therefore the total number of possible answers will be equals n to the power of r equals 4 cubed is equal to 4 times 4 times 4 equals 64. Out of these 64 possible answer, only one way to get all answer correct. Hence, the number of ways in which a student can fail to get correct answer is 64 minus 1 is equal to 63. Example 22. A student has to answer 10 questions, choosing at least 4 from each of parts A and B. If there are 6 questions in part A and 7 in part B, in how many ways can the student choose 10 questions? Let's explore all the possibilities. First, 4 from part A and 6 from part B. It means for part A, 6C4, and from part B, it is 7C6. Total number of possible combinations are 6C4 times 7C6 equals factorial 6, divided by factorial 4, divided by factorial 2, times factorial 7, divided by factorial 6, equals 15 times 7 equals 105. In second scenario, 5 from part A and 5 from part B. It means for part A, 6C5, and from part B, it is 7C5 total number of possible combinations. Our 6C5 times 7C5 equals factorial 6 divided by factorial 5 times factorial 7, divided by factorial 5, divided by factorial 2. Equals 6 times 21 equals 126. In third scenario, 6 from part A and 4 from part B. It means for part A, 6C6, and from part B it is 7C4. Total number of possible combinations are 6C6 times 7C4 equals 1 times factorial 7, divided by factorial 4, divided by factorial 3, equals 35. Therefore, the required number of ways is equals 105 plus 126 plus 35 is equal to 266. Example 23. A boy has 3 library tickets and 8 books of his interest. In the library, of these 8, he does not want to borrow Mathematics Part 2, unless Mathematics Part 1 is also borrowed. In how many ways can he choose the 3 books to be borrowed? Let us understand. First case. When boy borrows Mathematics Part 2 and Mathematics Part 1 also. Now he is left with 1 ticket and 6 books to choose from. So the number of possible choices is 6C1 equals 6. In second case, boy does not borrow Mathematics Part 2. Then the number of possible choices is 7C3 equals 35. Hence, the total number of possible choices is 35 plus 6 is equal to 41. Example 24. In a small village, there are 50 families, of which 18 families have at most 2 children. In a family welfare program, 15 families are to be chosen for assistance, of which at least 12 families must have at most 2 children. In how many ways can the choice be made? It is given that out of 50 families, 18 families have at most 2 children, so other 32 families are of other type. For family welfare program, 15 families are to be chosen for assistance, of which at least 12 families must have at most 2 children. Let's explore the number of possible choices. Number 1. 12 families out of 18 families, having at most 2 children and 3 selected from other type of 32 families. 18C12 times 32C3 equals factorial 18, divided by factorial 12, divided by factorial 6, times factorial 32, divided by factorial 3, divided by factorial 29, equals 18,564 times 4960 equals 92077,440. Number 2. 13 families out of 18 families, having at most 2 children and 2 selected from other type of 32 families. 18C 13 times 32C2 equals 8568 times 496 equals 4249728. In third scenario, 14 families out of 18 families, having at most 2 children and 1 family selected from other type of 32 families. 18C 14 times 32C1 equals factorial 18 divided by factorial 14 divided by factorial 4 times 32 is equal to 3060 times 32 equals 97,920. Fourth scenario. All 15 families having at most 2 children. 18C 15 equals factorial 18 divided by factorial 15 divided by factorial 3 equals 816. Hence, the total number of possible choices is 24C 12 times 26C3 plus 24C 13 times 26C2 plus 24C 14 times 26C1 plus 24C 15 equals 92077,440 plus 4249728 plus 97920 plus 816 equals 96425904. Thank you very much for watching the video on permutations and combinations. Please continue to watch our other video by subscribe this channel. Thanks again.